Okay, what's going on is this is practice 10-4. I don't feel like I have everybody's attention. This is the cone. This is the one that has its own little formula. You can't figure out this formula by yourself. Okay? And good. Now, here we go. It is asking for the lateral area of a cone. Now, I would like for everybody to imagine, if I were to take a cylinder, and I would roll it, what would happen to it? Okay, it would keep going, right? So I take a cylinder, and I would lay it over on its side, and I would roll it. What happens? It would just continue to roll, right? But if I take a cone, and I lay it over on its side, and I roll it, what would happen? It would come back to a circle, right? So if you want to see what it would look like on a circle, maybe this will happen, maybe it won't. What will happen is, if this is where the cone starts out, right here. Sorry. What would happen is the cone would start rolling here, and it would go all the way around to here. So whenever they shaded the blue, they just shaded the part that's not included. Okay? So this is the shape that it would look like. It would be a circle. It looks like that. Now, whenever you're going back to the lateral area of a cone, the formula is pi times r times L. And what is L? The slant height. This one always reminds me of Superman's real name. That's how I got it. Anybody know Superman's real name? Clark Kent is his super identity name. You know his real name. Okay? Okay. So here's the explanation of Superman. What planet is he from? Krypton, right? So, okay. Wow. Y'all don't really let me do my thing, do ya? Okay. So, forget all of that. Pi times R times L. So, pi times R, how much is the R? 9. So, pi times 9 times L. L is the slant height, which is on the outside of the cone. It's not the 20. It's not the 20. The L is not the 20. Because the 20 is the height of the what? The whole thing. The L is the slant height. It's going up that slope. So now we have to figure out the slant height. So the slant height, you're just going to use the Pythagorean theorem. So you're going to take the square root of 20 squared plus 9 squared. Daniel Qualls, what did you get?
21.93.
21.93 centimeters, just centimeters.
Yeah, you don't square this.
Okay? So that's the slant height. So you take that number and you put it in for L, 21.93. So whenever I take 3.14 and I multiply 9 and I multiply 21.93, I get 619.74. 619.74 centimeters squared. Now, again, let me give you my disclaimer. Some of you are using 3.14, some of you are using the pi button. I don't care which you use. So there's going to be a tolerance. If you are within one whole number of my answer, you're going to be fine. So if I get 6.19 or 619.74 and you get 620, are you within one whole number? Yes. So did you get it right? Yes. Now that's the lateral area. Now for bonus, just because we can find surface area. Surface area is always the lateral plus the base. But in a cone, how many bases are there? Just one. If it were a prism, they would have two bases, but it's a cone, so it only has one base. So I'm going to take the lateral area, 619.74, and I'm going to add it to the area of the base. But for a cone, what is the shape of the base? It's a circle. So what's the formula for the area of a circle? Pi r squared. So whenever you plug it into your formula, you're going to do plus base, which is pi times, what's my r? 9 squared. So your final answer is 619.74 plus 3.14 times 9 squared, which is, I'm getting 874.08.
Okay, so if we, okay, so if we write the yellow number, that's fine, and if we write the purple number, that's